I have a video on how to find a quadratic equation when given points. Remember, we've got these three types of forms of equations we can work with. Standard form, which is y equals ax squared plus bx plus c. In standard form, the AOS, the line of symmetry, is at negative b over 2a. To find the vertex, you take that value and plug it into x. You would plug it in here and here and calculate the vertex. And the y-intercept is always c. With the vertex form, the vertex is at hk. It's pretty convenient. And with intercept form, you have roots at p and q, which are the opposites of those numbers. Roots are at p and q. And then the AOS is halfway between p and q, which is p plus q divided by 2. And you can, again, do f of p plus q divided by 2. Plug that in to find the vertex. That's all review of stuff we've learned, and also I don't know how to write the word vertex, apparently. Always remember that for all forms, A is the first step from the vertex, the dilation factor that changes the 1, 3, 5 pattern of growth, multiplying that. So, the type of info you have affects the form you want to use whenever you're making your equation. Here, I have a vertex. Since I have a vertex, I'm going to use vertex form. In this case, h is negative 4, k is 5. So I could have y equals a x plus 4 squared plus 5. I just found h and k. Now all that's left is to find the a value. Well, in this example, there are two ways that we can do that. I can very clearly see the first step from the vertex is down 2, right 1, which means my a value is negative 2. So my equation would be y equals negative 2 x plus 4 squared plus 5. And you've got it. But supposing I didn't see that, or suppose I had some other point, like suppose this wasn't the very first point from the vertex, but something else. Well, I could take any point I'm given and plug in these values for x and y. So I was still dealing with this equation. And I don't know the a value. Well, to find the a value, I could plug 3 in for x and negative 3 in for x and 3 in for y. I plugged in negative 3 for x right here and 3 for y. And I solved that for k. So 3 would equal a times 1 squared plus 5, which means that 3 equals, 1 squared is just 1, and 1 times a is a. 3 equals a plus 5. So a equals negative 2. Just like we got up here. In this parabola, I don't have a vertex, but I do have two roots. So using intercept form here makes a lot of sense. I know the formula for that is y equals a times x minus p and x minus q. Well, p and q are going to be 2 and 7. So it's y equals a x minus 2 x minus 7. Now I can't really tell what the first step is. It looks like, from here, if I'm going to go to the right one, it looks like it's 1 or 1.5 or 2. I don't really know. So I can't just tell by looking at the vertex. But what I can do is pick some other point and plug it in for x and y. So I'm going to have negative 8 equals a times 3 minus 2 times 3 minus 4. So negative 8 equals a times 1 times negative 6. Negative 8 equals negative 6a. Divide both sides by negative 6. That's 8 over 6, which is 4 over 3. A is 4/3. So we get y equals 4/3 x minus 2, x minus 7. Beautiful equation for that graph. Here, I don't have a vertex. I don't have roots. I don't know much of anything. If I were really on top of my game, I could tell that the AOS is going to be halfway between these 2 points. So it's going to be at 2. There's an AOS at 2, which looks like it's here. Yeah, I could play with things like that and work with that. I would now know that negative b over 2a equals 2 and play with that. But instead, what I'm going to do is if I don't have any good information, I have to use standard form. But I do have one piece of information. The y-intercept is negative 2, which means that my c value is negative 2. So I have y equals ax squared plus bx minus 2. And I know that halfway between these is the AOS because they're symmetrical and these have the same y values, so they're on the horizontal line. So the AOS is at 2. So negative b over 2a equals 2. That doesn't actually help me though because I've got two variables there and I can't solve this equation without knowing a or b. So now here's what I can do. I can take two other points that I haven't used. I've already used this point, so that point's no good. I used it to get this value. But I can take this point and plug them in for x and y twice. By that I mean I can take 1, 1 and have 1 equals a times 1 squared plus b times 1 minus 2. That was me using this point. And I can take 4, negative 2. Negative 2 equals a times 4 squared plus b times 4 minus 2. And now this becomes 1 equals a plus b minus 2. That was the top equation. The bottom equation becomes negative 2 equals 16a plus 4b minus 2. I can add the 2's to both sides to get 3 equals a plus b and 0 equals 16a plus 4b, and then solve this using substitution or elimination. It's a system of equations now. With two variables, two unknowns. Two equations. So if I work through that, I could get like, if I substitute, 3 minus a equals b is coming from this equation. Take this and plug it in for b. Subtract 12 from both sides, a equals 1. Negative 1, excuse me. Now I know that a equals negative 1, take this and plug it in here, b equals 4. So I'd have the equation y equals negative 1x squared. Look, it's right here. My b value is 4, so plus 4x minus 2. That was me given a y-intercept. So when you don't have good information, you have to use standard form. Now I'm going to show you how to do it on your calculator a couple of ways. I'm going to take those same 3 points that we had and show you two different ways to find the equations from 3 points. You have to have 3 points to get the equation. With 2 points, that's not enough information. It takes 3 points. One way is by running a regression. A regression is like a line of best fit. Students have asked me in the past, how do I get points into a table on a graph? Now, one way is to like set your y equals and plug in an equation here. But here we don't have an equation. How can I just plug in points? To plug in points, you press the stat button, which is right here. And I'm going to edit. I'm going to edit L1. This stands for list 1. And in L1, I'm going to put my x values, 0, 1, 4. In L2, I put the y values, negative 2, 1, negative 2. So this is the point, 0, negative 2, 1, 1, 4, negative 2. Then I'm going to quit out of here. Press the stat button again. This is me, the steps are right here. I just did this. Now I'm going to do this. I'm going to press stat, scroll over to calc, scroll down to quad reg, which means I'm running a quadratic regression. A regression is like a line of best fit. It's going to find the points that best fit those three, find the curve that best fits these 3 points here. So I press enter a few times. It's a is negative 1, b is 4, and c is 2 in this equation. A is negative 1, b is 4, c is 2. So you can do that whenever you've got 3 points. You can just find the regression to find the equation that matches it. The other option, and this is a little bit more involved in some ways, is to use matrices. So I'll show the matrix method over here. I take the equation y equals ax squared plus bx plus c, and I plug in my x and y values 3 times. So negative 2 equals, is this going to work? I'm not sure. Let's find out. A times 0 squared plus b times 0 plus c. Then 1 is going to equal a times 1 squared plus b times 1 plus c. So I'm plugging these in for x. And then negative 2 equals a times 4 squared plus b times 4 plus c. And then I simplify this and I get negative 2 equals c for my top equation. my next equation becomes 1 equals a plus b plus c. And the bottom equation becomes negative 2 equals 16a plus 4b plus c. And this is now a 3 by 3 system. 3 variables, 3 unknowns. I'll call this 0a, 0b, and 1c. And remembering matrix equations, I can solve the matrix equation doing A inverse times B. So matrix A is now going to be 0, 0, 1, 1, 1, 1, 16, 4, 1. And matrix B is going to be negative 2, 1, negative 2. And I'll do this in a matrix. Touch my matrix, scroll over to edit, edit matrix A and make it a 3 by 3. I have 0, 0, 1. And then I have 1, 1, 1. And I have 16, 4, 1. And I'll quit. Make sure that's a 1. Then I'll quit and edit matrix B. Edit matrix B, it's going to be a 3 by 1. I'm going to go negative 2, 1, negative 2. I do A inverse times B. Negative 1 for negative 2, just like we got every place else. Negative 1 for negative 2. That was a negative, I just didn't write it down. So there's a whole bunch of ways to find a parabola given 3 points. If all you're given is just 3 random points, those 3 points can make a parabola. There's some parabola that fits through those 3 points, provided they don't fall on one line. So you can find it with a regression, with a matrix, or you can graph the points like we did here. This is like being given 3 random points for all these problems. Graph the points and see how it looks. Thank you. Have a nice day.